Hello, we're going to go ahead and do a demonstration of polymorphism. And let's start with the definition of polymorphism, and then I'm going to give you a code example. And why don't I go ahead and type this out where we're going to be working today, which is going to be in Visual Studio. And so what polymorphism is it's the ability for like objects, objects that are the same, but also can behave differently. So this kind of gets into one of the reasons for virtual functions, in dynamic binding, is to implement polymorphism. But you don't need virtual functions to implement polymorphism. You can use them. They're good to use to implement polymorphism, but they're not a necessary thing. And this is all part of relationships of a has-a relationship and inheritance. So what we're going to do is we're going to do a simple demonstration. Now, the way I'm going to do this is not particularly the way I'm going to do it for a demonstration, meaning that I'm going to be putting all the objects in one file when they should be in separate files. And I'm going to do inline functions, which you should begin all your header files with, and then move to implementation. So just remember that these objects that I'm declaring, you would put in a whole nother file and use an include statement. I do this for a reason, because it's easier to see the relationships when you have just one code file, just for beginners. So what we're going to do is we're going to do top-down definition and then main. And we're going to program an inheritance hierarchy that starts with an object called animal. So let me zoom in here, and we're going to go ahead and get an object called animal. And what I want to do is I want to store some private information, and I want to have some public information or public actions. So with the definition of polymorphisms, that objects are the same but also can behave differently. What we're going to do is we're going to model an animal that has an action, and the action is to eat. So that's what we refer to as runtime code or a function. So of course we're going to have something for the animal, such as a name, and we can set up some getters and setters for that, but I'm not really too concerned about that, because I'm showing you the behavior of polymorphism. So what we'll do for an animal is we want to make sure that our inheritance hierarchy starts at the base class with a very generic definition, and then as you go up and you derive from your base class, you go up in specification. So let's say that we have animals. Well, we got different kinds of animals. We got a cow, we got a tiger, we got a lion, we got all kinds of different animals. How about saber-toothed tiger, which would be even more of a specialization. So your base class you want to make as generic as possible, so that you can take this base class and use it for all the different animals you have, and I'll have to rewrite that part of code. And that's one of the main things for inheritance is to have this inheritance hierarchy before you know it, a whole technology is built. In fact, this is the way C# was developed and Java was developed, is all object based with a low level object that everything inherits from. And as you go up the inheritance hierarchy, things get more specialized and more useful. And then the more code that you can use for other types of objects. So this is kind of an example of that. I'm going to be as general in terms so that you can understand kind of how it goes together. So the action that we're going to want animals to all share, or the data that we want all animals to share, is a name. And so any other pieces of data that all animals have we would put in this class animal. Now, all behaviors that all animals have, we would put in this class animal. So one behavior that an animal has is to eat. And then you think, well, what do all animals do when they eat? And then, well, they could also eat differently. And so we're going to be having objects that are the same that can behave differently. But the action itself at the animal level will be the behavior that an animal has. So you want to think of an animal as all animals, that action that all animals do, no matter what, is eat. So what do they all have to do to eat? They all have to open their mouth. So we're just going to do a simple see out here to give you an example, because we're going to be putting this all together to demonstrate how they behave differently and also the same. So it's going to be opens its mouth, and now this is where we stop, because animals all eat the same. They all have to open their mouth, but they don't all, eat the same thing. So our action at this level has to be something that is something that all animals share. Now, when we go in and we apply this to an inheritance, what we're going to want is we're going to be more in specialization. So we're going to have things a little bit more concrete. This is our generic base class. But what we want is we want to essentially take that and inherit from the animal. But let's say that we want a cow that inherits from animal. And in that cow, we don't need the string name. Let's just say that this cow, Control Z is your best friend. This cow, let's say, what do all cows have? Well, what do all cows have? Okay, no, udders. Let's just say this is something to describe an udder. Udder size. Well, actually, that's they actually have cows that they milk where they detect the udder size, and the robot milks them. So I guess that would go. And here's the thing, though, is a cow is going to eat like an animal. But it eats differently. So we're gonna first make it open its mouth, but it's gonna eat grass. Now this is all gonna come together with the name resolution operator. And what we're gonna do is I'm gonna show you how this all kind of goes together, so that you can see the mechanisms involved, because I'm showing you polymorphism without virtual functions. I'm showing you how it's done at a lower level, so that you can understand it without the virtual function part to it. So we're just kind of discussing just polymorphism now. Just know that when we start discussing virtual functions, it's a mechanism to implement or dynamic binding is a way to implement polymorphism, but it's not the only way. It's just a way. So I'm going to show you how an animal eats and how a cow eats, and then we're going to get the cow to eat like an animal, and then like a cow. So let's go ahead and just look at what we have. Review. We have an animal that opens its mouth, and then we have a cow that eats grass. Doesn't the cow have to open its mouth before it eats grass? Absolutely. So, but let's just look at what we have. So we're going to have animal here. I'm just going to call it AN. And then we're going to have a cow here that I'm going to call Betsy, because all cows' names are Betsy. And what we're going to do is we're just going to do an AN dot eat, and then we're going to do a Betsy dot eat. Okay, so what you're going to see here is we have an animal, and then we have a cow that is also an animal. So I'm gonna set a breakpoint so you can just look, so we can see kind of what's going on. Okay, here we go. So here is my instantiation on the stack. Then our animal eats. I'm going to do a step into so you can see kind of what's going on behind the scenes. I do a step into and it goes into the animal as expected, and the animal opens its mouth. Then we go into Betsy, and we see that we go into Betsy's eat function, and Betsy just eats grass. Betsy didn't really open her mouth, which is a problem. So when you do polymorphism and inheritance hierarchies, it's expected that you do the portions of your behavior in the base class and then finish it in your derived class. So we've got to call to the part of the cow that is an animal and tell it to open its mouth. So Betsy is not even trying to eat grass, but it hasn't opened her mouth yet. So this is just an example. So what we need to do is we need to tell Betsy, and here's our output, opens its mouth and eats grass. Well, the animal was opening its mouth. Betsy wasn't opening its mouth. So if we just have Betsy eat and we get rid of the animal, Betsy is going to have a problem eating grass without opening her mouth. So, and you do this in the derived class. You call to the base class's behaviors. So what we need to do is we need to go to the part of the animal that is a cow, and or part of the cow that is an animal, and tell it to open its mouth. Now in other languages you do a base dot call and whatnot, but since we're working with Frankenstein and Mr. Upgraded and Band-Aided language, we use the name resolution operator. So we're going to say go to the part of the cow that is an animal and eat. When that's done, you have the cow eat the grass. So let's look at this behavior. So I'm going to go ahead and have our cow eat, and we're going to do a step into. Okay, step into, remember that's F11 on your key. Okay, there I stepped into. Okay, so I go, now since this is top-down binding, this is not dynamic binding, it's going to go to the cow's eat function. And we're going to probably come back to this a little bit when we talk about dynamic binding. Here is the cow that inherits from an animal. We go to the cow's eat function first and then say, oh, wait a minute, we're an animal. We've got to eat like an animal first before we eat like a cow. So then what happens is that goes to the part of the cow that is an animal. Let's do a step into. Now it goes to the animal's eat function. So objects that are the same but also can behave differently. So I'm setting up the ability to behave differently here with our animal object and our cow object, because we're going to add another animal here that eats differently. But Betsy is having a good time opening her mouth and eating a chunk of grass right now. So you see how that polymorphism, this is just the setup. We call to the base class for the initial generic behavior that all animals share, and then we finish up with the behavior that is specific to the cow or the derived class. So you can see that Betsy is feeding along pretty well right now. So what we want to do is I'm going to demonstrate. Let's do just real quick again through that walkthrough. I do a step into F11. I go into the eat function of the cow. Then I immediately call the animal's eat function. do a step into here. The animal's eat function is called. The animal opens its mouth, and then it comes back to the calling place of the cow's eat function and completes the behavior or the specific behavior for the cow. And then the program is done and Betsy is no longer hungry. Okay, so now we get into the next bit. And the next bit is, well, we want more specialization. So instead of having a cow here, we can have our tiger. And our tiger is going to inherit from animal. And all tigers have a claw size. And all tigers have to eat. But a tiger is different from a cow. However, it's also the same. Because a tiger has to open its mouth too. But a tiger does not eat grass. A tiger eats meat. Okay, so let's create our tiger and let's look at kind of what we got here. We got tiger, Simba. I think he was a lion. Yeah, he was a lion. That would be usually the what I would get from the peanut gallery. So here we go. We got Betsy that's going to eat. Then we're going to have our lion that's a tiger, Simba, eat. Okay, so this goes to the very definition of polymorphism. Two objects that are the same. A cow is an animal. A tiger is an animal. They're the same. They can behave the same, but also can behave differently. So they have to behave the same by opening their mouth, but also differently by eating grass versus meat. Okay, so let's go ahead and test our tiger. Okay, let's do a step into. Oh, not there. There we go. Step into here where Simba's going to eat. Okay. So our tiger is going to eat, and our tiger is going to open, our lion, whatever. Our lion or tiger is going to open its mouth, so it's going to behave the same or be the same. Actually, objects that are the same okay, let's change this. That behave the same, but also behave differently. That's a better definition. So here we go. We've got the animal, the tiger eating. The tiger opens its mouth. So do a step over. Okay, we have our output of opens its mouth. Looks like we got an output from the previous. So let's go ahead and start over because I kind of messed things up with changing the definition. Okay, so let's shut some of these things down here. Make sure I get some good output, and let's set the breakpoint where I actually want it, which is where Simba or lion eats. And okay, so step into here. Okay, we're going to go to the tiger's eat call. Step over. Step into here. The tiger is going to eat like an animal, behave the same, and open its mouth. And then we come back, and this is where the tiger behaves differently than a cow. So they behave the same. They both eat like an animal. But they also behave differently. One eats grass, and the other one eats meat. Okay, so we have our tiger that opens its mouth and eats meat. The other output is from Betsy. I was thinking we got two, but this is our tiger eating right here. We got our cow eating grass, and our tiger eating meat. So that's polymorphism. It's not something that's really too, you got to understand the relationship of inheritance and how behaviors and the idea of generic. So a base class is always generic, and as you inherit up the spectrum, you can have it more specialized. So let's say that, okay, well, let's say that I'm building a game and I've just rendered tiger and cow, and let's say that I want a mutant cow. So I can actually take this mutant cow class and let's say it's a mutant cow, no, cannibal cow. It's a cannibal cow, but this cow is going to inherit from cow. And we might be wanting to change a few things. Cannibal cow is probably horrible. Maybe I'm going in the wrong direction. Super cow. Super cow inherits from cow. First thing we do is we go to the cow's eat function. That then goes to the animal's eat function. And a super cow is, let's just say that it doesn't have any data. And the cow is going to eat. Then it's going to fly away. All right, I think that's a better direction than the cannibal cow. Okay, so now let's look at this. Let's create our super cow. And our super cow is called Super Betsy. Okay, now let's have our Super Betsy eat. So this is kind of the idea of generic going from generic. So now I've got the lower level, very generic, more specific, and then another derived class that inherits from cow that's even more specific. And that's how you can build a whole technology and reuse code that you've already built. And again, I go back to C# and Java. That's how those languages were created. C# has a base object called object, and everything inherits from that object class in the whole language. So let's go ahead and go to our example here. Go ahead and run it. Okay, there's Super Betsy is going to eat. Step into. Step over. Okay, Super Cow is going to eat like a cow. But before Super Cow can eat like a cow, Super Cow has to eat like an animal. So Super Cow opens its mouth. Super Cow then eats grass, comes back. Then it comes back to where Super Cow flies away. So we have a Super Cow that opens its mouth and it's grass. Oh, did I say really it's grass? Oh, that should be eats grass. Eats grass and flies away. Okay. Oh, I did it on both of them. Eats meat. Eats grass. Okay. And flies away. All right. So we're not going to step into it this time. We're just going to do the final example output. Opens its mouth and eats grass and flies away. There's a lot of ands there, but I think you guys get the point and the understanding of what polymorphism is. Thank you.